All right, so I think this is recording. Let's take a look here. Problem number 7. Our parent function is the square root function. We have 4 transformations that we want to apply to this function to get to our new function. The first transformation is a horizontal shift, a shift to the left 5 units. Then our second transformation, a horizontal stretch by a factor of 4. And then, so the first two transformations are affecting the x-coordinate. And then the reflection across the x-axis, that's changing a y-coordinate. What was up is now down if you're going across the x-axis. And then shift the resulting graph down 3 units. That's also affecting the y-coordinate. So our affecting the x-coordinate is before we apply the square root, so it's going to be underneath the radical. So to shift the graph to the left 5, we actually add 5, and then we take the reciprocal of 4, which is 1/4, and that'll be a horizontal stretch by a factor of 4. And those are the two transformations that are affecting the x-coordinate. To reflect across the x-axis, we need to take the opposite of the output of the function, and then to shift the graph down 3 units, we need to subtract 3. So here's our final answer, and we can check that final answer. We could go to the Desmos graphing calculator and treat each one of these transformations separately to see if it actually does build up to this g of x. So we can definitely confirm whether our answer is correct or not. So we've got our square root function, and if you abbreviate square root function that's not SQR, when I type the T, it turns into a radical. And let's slide this over so I can see what I'm doing here. There's our parent function. Now, our first transformation was a horizontal shift to the left. That was x plus 5. And our second transformation affected our the result of our first transformation. That was a horizontal stretch. So I've got 1/4. Oops, I'm trying to use function notation. I suppose I don't have to use function notation. There. Sorry about that. And then the third transformation was affecting the y-coordinate, and it was a reflection. And then the fourth transformation was to shift that resulting graph down 3 units. And let's look and see what all these transformations got us. So our original one was the square root function. Then we went to the left 5 units, and then we worked on that resulting graph, and then we wanted to horizontally stretch it by a factor of 4. So this -5 gets multiplied by 4 and gets -20, so it's stretched way off to the side here. We can see there's our -20. So now that this is going to reflect across the x-axis, and then this is going to push it down 3 units to our final answer. All right, now I claim that that graph will be the same graph as our final answer was, which was negative square root of 1/4 x plus 5 minus 3. I claim that this green graph is the same as that blue one right there, and it is. Now, when I first started keying these in, I wasn't using the function notation, and I suppose I could do that, because if you use the function notation, I can come up and change this x square root of x to a different function, parent function, and I can come in down here and make this, what did we say, 1/4 x plus 5 squared. And I can do all these same steps to a different parent function, to go to the left 5, then a horizontal stretch by a factor of 4. This x-intercept of -5 still gets pushed out here to -20. Then we reflect this across the x-axis. Then we push it down 3 units. Then we check our answer, and hey, it's the same. That's the advantage of using this function notation, that the graphing calculator, we can come in and apply these transformations to any parent function we want. Now, if we didn't want to do it that way, we could still come in and say, okay, my first transformation is the square root of x plus 5. And then that will build upon, in my second transformation, will be the square root of 1/4 times x plus 5. And then the reflection of that across the x-axis. And then finally, to push it down. So you can see I wasn't building off the previous graph, other than to just, now this is all specific to the square root of x. So if we look at what's going on here, we're starting with this parent function, the square root of x. We're shifting it to the left 5 units. Then we've got a horizontal stretch by a factor of 4. So this -5 times 4 is out here at -20. And then this is a reflection across the x-axis, and then this pushes it down. Oops, I didn't change that to square root. I could just say 1/2 here. That's the same as the square root, but here, let's just delete it and square root 1/4 x plus 5. And so, you can see that we built it up. Shift to the left, a horizontal stretch, a reflection, and then down And that's our final answer. So it all checks. All right. So I hope that helps, and I'll talk to you later. Bye.